more about structural engineering or water resource engineering or structural design, uh, basically you studied strength of materials in your MTech. No, sorry, in your
Yes.
mechanical. Basically,
Yes, sir.
you studied well strength of materials and fluid mechanics. So
Yes,
the
sir.
basics of strength of materials and fluid mechanics is very useful. Those are the fundamentals and basics for these subjects, which was advanced on those basics. So basically, structural engineering is very pivot for the structures where we are going to construct dams or canals or whatever, any canal linings or any canal structure, any bridge. Basically, irrigation, as you are in the uh, irrigation department, you are used to construct more bridges, check dams, canal linings and canals, and some pump houses like that you are going to do. So
Yes.
in that manner, you need more structural point of view, and also you have to understand the structural stability of the structure and the detailing of the reinforcement and everything. So these everything will be covered in the structural engineering, sir. Moreover,
Yes, sir.
in water resource engineering, basically what are the things we cover, we'll see in the next slides. So
Yes, sir.
fundamental, actually structural engineering, basically I am the structural engineering. I do maybe you may get some PDFs, no sir, to your office that there is some design like CC concrete design designs will be given to you, and bar scheduling detailing will be given to you. So
Yes, sir.
those will be done by CAD engineer or STAT Pro engineer or structural designer. So myself, I have thorough experience and I have a very practical knowledge in CAD drawings and STAT drawings also. Myself, I do the designs.
Okay,
So,
okay.
uh, so this is the foundational concepts we need in the structure. So generally, design and analysis, those are the basic two things in the structural engineering, sir, basically. So
Yes.
structural engineering is divided into two parts. One is design, another is analysis. So generally what we do is in structural engineering, we more focus on design. Generally, after analysis only, we tend to do the design generally.
Yes,
So
sir.
after
Yes, yes.
analysis of the structure, we do design. So how to do the, so for example, if you take any example like uh, for example, if you want to build a G+5 building, we need
Hmm.
first architectural plan. What is that
Yes.
architectural plan means? For the architectural plan, where should be the room? What is the size of the room? What is the thickness of the wall? What is the area of the hall? What is the carpet area? And what are the things I have to put? What is the functionality of the building? What is the elevation of the building? What is the build-up area of the building? Everything will be decided by the uh, architectural plan. So that will be
Yes.
done by the
Basically, we have to
architectural.
consider answer. Answer.
Yes, sir.
Hmm.
So after that architectural plan, the same plan will be pushed to structural drawing person. So what he will do is taking the measurements from the architectural plan, we do the analysis. We do the analysis and we do the bending moment, shear force, torsion, everything we do all these design aspects. At the final day, what we'll try to do is we'll give you what is the best economical cross section of the beam, what is the best economical cross section of the column, what is the best economical cross section for the slab, and what are the loads happening, what is the functionality of the building. By knowing the functionality of the building, we apply the loads on that structure in some softwares like stat pro, revit. So in those softwares, we assume some loads on that building, depends upon the functionality of that building. We take the measurements given from the architecture, so we place same measurements there. And what we do is at the end of the day, as a structural engineer, we deliver the cross sections of the every element in the building. This is the general process happening in the market. So
Yes, sir.
whereas as a construction AWE or construction DE or executive engineer, whoever, so generally AWE or AE, we are section engineers. Basically, we are field engineers. So our Ds and Es are the office staff. They don't involve in those. They just pass on the files to us. So they pass the files
Yes,
to
sir.
us to execute that thing. So every day we are in the site. So Ds and Es, maybe they came from AW background or A background, but when they came to D and E position, they don't look after what are the pains we going through. So what generally in department, sir, very well. Maybe generally in an
Yes, sir.
outside market, we apply a factor of safety 1.5. But
Yes, sir. Okay.
in department to enhance the project cost, for example, if government wants to do corruption in that project, what they will do is simply they will increase the cost of the project, right? You know very well.
Yes.
So
Yes, sir. Yes.
in that manner, what they will do, factor of safety is not 1.5 here. The factor of safety will be here 3. So big columns, big beams, big slabs, and everything will be steel. Also, instead of using 12 bar, they will use 20 bar. Sir, why are you using this? Means no, nothing. You can't discuss in the field. What is in the paper? Just follow it.
Yes, sir.
It's okay. So like that we do. So generally, construction of buildings, bridges, and other infrastructure, it is a construction practice. We have to know that principles. So in basically structural engineering, we need more principles. So I will cover in the coming classes, sir. So
Yes, sir.
generally,
Yes.
what is the importance of structural engineering, very, sir, very well in strength of materials, that is bending moment and shear force.
Yes,
These two
boss.
will play major role in structural engineering, sir. It will play
Yes,
more
sir.
role. Okay.
Yes.
So at the end of the day, as a structural engineer or executive engineer, or while we are construction, when we are in the construction wing, we are bound to do the structure in a very safe and stability. So in that point of view, structural engineering ensures very safe and stable and functional infrastructure. There are some structures in India itself where they constructed it. They have given so many funds for that. They constructed it, but so many buildings in India which was mostly constructed by government departments, even though the contractor may be from some agency, some big companies like Pedareddy, like that. Even though they
Mm.
constructed it, government don't know how to utilize that functionality, how to utilize that building in basic functionality. So in that point of view, any structure which is leads to functionality only, then building is a safe and stable building which was tend for functionality.
Very much. Sir.
So these are the structures, in very engineering, sir, buildings, bridges, towers, and dams. So the subject you related maybe these bridges and dams. Yeah, no, sir. Basically, you don't have. I don't tell that you don't know anything, but I assume that you know something about concrete. As for you
Yes,
have
sir.
some 6 years of experience,
Yes, sir.
know little bit about the concrete, sir. But I will tell you some of the things which you didn't listen till now. In the next coming
Yes.
classes, if you like my demo, if you interested in my demo class, so I will
Yes.
explain. There is a one concrete technology subject is there, sir. It will take nearly 15 classes itself. So in
Yes.
that concrete technology, I will explain everything in detail. There you can
Okay.
understand what is concrete and what is the story of the concrete itself. Correct.
Mm.
So
Mm.
next is steel, sir. Generally, in structural engineering, we deal more in concrete and steel. Obviously, you know very
Yes.
well, concrete will have more compressive strength, steel will have more tensile strength. That's why the members, even though it is cantilever, fixed, or simply supported, or any overhanging, any type of structure, these two materials are basic materials and important materials. There are replacements for these materials also. For example, For concrete, there is a replacement. For steel, there is no replacement. Why? Because studies are going on to replace this steel. We need same properties of the steel which was replaced by some other material. It also should have the same properties what steel has. So
Sir,
concrete
steel,
is.
sir, hello.
Sir, tell me.
As you said, steel, we can't change it. But instead of concrete, what you can change, sir?
No, yes, sir. I will tell you. So instead of in replacement of concrete, we are using
Mm,
types of
mm,
concrete. For example, glass fiber concrete, plastic fiber concrete, green concrete. So we are giving some changes in the cement and admixtures of the cement, and also the mixer of the concrete is changing day by day. It depends upon the studies. So we are actually, I think you know very well, sir, when you are preparing for AWE, when you studying when you were studied general studies, you may
yes,
came
sir.
across about Paris Agreement, right? So in polity,
Yes.
you may came across Paris Agreement. What is that Paris Agreement
Mm,
2015 means? We have to
mm,
reduce the carbon emissions by 2030.
mm,
So
mm.
the majority of the carbon emissions are occurring by cement generally.
Yes.
So we are
Yes.
making every land in a concrete jungle. We are using so
Mm,
much of cement in cement. So by using so much huge amounts of cement in this world, creating so much of carbon emission, that carbon emissions gives us the pollution. Thereby, the global warming is happening. So the key feature or the key material which is causing that global warming is comes from our structural engineering. That is the name called concrete.
yes. Yes.
So second one is the third one is timber, sir. There is no point of discussion there. So that is about the materials. Now introduction to the structural analysis. It is crucial for effective decisions. So for that for that also I'll mention. So what is structural design? It is not about the lines on the sheet. It is not the drawings which is daily watching by us. This is not only about the lines, but what is structural design means it has some purpose and it has some relationship to the structure. So if you want structures to be safe, stable, and efficient, we have to understand loads. Isn't no, sir? If you don't know the loads which are happening on the structure, you can't design it. Isn't
Yes.
right?
Yes.
So we have to know the load, sir. What is that load?
Yes.
Obviously, every structure will have dead load. Obviously, depends
Yes.
on the functionality, it will have some live load. If
Yes.
for that example, if the structure is above 5 meters or 7 meters, obviously wind load will act. If that if that area is prone to some seismic area, seismic load also will be considered. So by
Okay. Mm,
applying all these loads on the structure, we have to get the design of the structure which can withhold all those loads. At the same time, it has to give a functionality for the purpose. So that is the basic
yes.
structural design involves. So
Okay.
so there is a lot of difference between design and analysis, sir, that we will discuss in the further classes.
Yes, sir. Yes.
Next, design process steps. What is the process? First, we have to understand conceptual design. What is the design actually? How much area we want? How much carpet area we need? What is the functionality of that building? How many rooms we want? Or what is the span of this bridge? So what is the canal it has to pass on? Or what is the canal width? What is the canal depth? What is the canal sloping? What is the
Yes.
bed depth? Everything depends
Yes.
on the conceptual design. This is just it is an ideal generation. For example, As for your irrigation department is concerned, you only think about how many cubics of water is going through that canal. That is the
Yes.
basic idea. So this
Yes.
many cubics of water is going from A channel to B channel, B channel to C channel. There will be a check dam to hold on that water for some time. So for this whole process, you should have some area, you should have some idea from A point to C point where it will go, what is the topography of that land, and what is the structure we have to build on that topography. Depends upon the topography of the land we have to design. Otherwise, if from A channel there will be black cotton soil, for B channel there will be rocky soil,
Yes.
for C channel there may be some gravel or some sandy. So depends upon the topography of the land, your design will be different. So
Yes. Sure.
that conceptual idea, conceptual design is very important while we are going to the design process steps. Then load assessment. Load assessment is very crucial thing. Why? Because in recently in Telangana,
Mm.
government is taking one 2 BHK buildings project. It is doing.
Yes.
So it is
Mm.
doing 2 BHK government buildings for poor people, for below poverty line people. They are accommodating some families in that 2 BHK building, which was giving absolutely zero, absolutely by government without any single penny from the beneficiary.
Okay. Okay, sir.
So
Mm.
when that concerned minister visited that site, that slab was collapsed. When some 20 to 30 members of the minister group and IAS and IAS people and structural people and Panchayat Raj people, 20 to 30 people are standing on that slab. That slab all collapsed and that minister was uh, injured on that day.
Oh, yes.
So why? Because
Is it recently,
even
sir?
though very recently, sir, maybe in the
Okay.
last 3 months, I think in October or September, it was happened. It was very viral in the media. It was
Yes.
viral.
Yes. Yes.
So, why actually a slab is not able to, uh, the slab is not able to take the load of 30 members? Is a live load of 30 people? Design is clear, but construction where we constructed and where we have taken the quality material will also play a very crucial role in the structure. So before going to the where inside it depends on the structural engineer. Sorry, it depends on you and the company, isn't right? So
Yes. Yes.
when you are executing some bridge or some canal or some anything, the quality of the structure depends upon the execution engineer and also the agency. Simple. So if they
Yes. Yes.
compromised, everything will be compromised. If they don't
Yes.
compromise, so transfer will happen to you. That's the scenario will happen. So,
Yes.
but
Sir.
when you are coming to the load assessment, while you are doing
Mm.
the design process, load assessment is the crucial role. Why? Because here engineer, a structural engineer has to think visible loads and also invisible loads coming on the future. Then structural analysis, analyzing the forces and moments. Already I told you, sir, there are only two words which was you heard very well in your strength of materials will be here. That is forces. Nothing but it is the shear force and the
Yes.
bending moments in the.
Permitting method.
Then the very important thing is, sir, our structural engineering department has very good codes there, sir. There are very good codes. IS 456 2000, IS 456 2005, ISP 16, IS like that. There are, I didn't remember the numericals of the codes, but there are 5 to 10 codes are there where that codes will give us a very good knowledge to us to how to design that thing. So the the IS codes will give us very design checks. There are some checks will be there. So after design, after doing analysis, we'll get some cross sections. Then we have to check about the deflection. We have to check about the shear. We have to check about the bending moment. We have to check the serviceability also. So like this, we have to check. So in design process steps, we need concept, load assessment, structural analysis, and design checks. These are the important in structural design.
Yes.
As you know, dead load, live load,
Ah,
wind load, you know, we'll discuss in later. So we have design codes where are very good IS standard, Indian standard codes are there, IS codes, and also safety regulations. This is very
yes.
important, sir. Safety regulations. Why? Because you may came across one of maybe one or two incidents where it happened in your site. So safety regulations is also important, and uniformity standards also we have to maintain. Yeah, already I discussed this one. I'll go through now.
Yes.
So water
Yes.
resource engineering. So
Mm.
overview of water resource engineering is very simple, and it is also very good subject, and it is a very interesting subject.
Yes.
Why? Because you may know about discharge, sir. Q equal to AV, the formula.
Yes, sir.
From that simple formula, Q equal to AV, there are so many hundreds of formulas uh, came from that simple formula Q equal to AV. That Q equal to AV will define everything and every element of the structure in a different pattern. So
Yes,
water
I will
resource
decide.
engineering is yes, yes, sir. So management and distribution. Generally, water
Yes.
resource engineering is nothing but it's a management of water.
Yes.
It's a distribution of water. We have, if you want to manage the water, we need dams, we need dams. If you want to distribute the
Mm.
water, we need canals. That's the simple irrigation. So, flood control, planning infrastructure, water system effectively will comes under this one. So, to understand this water resource engineering, sir, you need to understand first basic is hydrological cycle. So, what is the
Yes.
hydrological cycle? What are the stages? What is the pros and cons of every stage? How it will affect the structure and how it will forces us to design the structure in such a way to overcome that situation will give us more uh, knowledge from this hydrological cycle. So you know
Yes, sir.
very well. Precipitation, rainfall, and snow are the primary water inputs. You know very well. So no need to discuss.
Yes. Yes.
So importance of
Yes. Yes.
water resource engineering essential for sustainable management of water resources. Then you know very water distribution systems. I will explain everything in detail, sir, in further classes. So these are the
Yes.
reservoirs, you know very well. Pipelines, you know, in pipelines very interesting subject is there about walls, about pumps, about the
Yes.
reservoir, then that is closed reservoirs, and what are the pressures we have to maintain, and what are the things we have to control from a construction engineer, and also about pumps is very fine. So irrigation engineering
Sir.
and structures will come here. The key concepts, equilibrium, compatibility, material behavior, we will see in this one. And
Yes.
structural elements overview, beams, columns, slabs, overall structure we will discuss, sir, generally. Load
Yes, sir.
combinations and design philosophy will come through. And generally